Okay. Welcome everybody. Let's see what we will see. So we're back together with voxel tools. Last time Zilan was here, so we were able to make quite a lot of good progress. This time I will play around a lot with experimentation and see whether I can actually start shaping an actual planet terrain. I need the terminal. So take me to coding, keycalls, and open me the build. Open me the file, the editor. Okay. So we have here. Let's see how well this works. Okay, so I have here my rotation, and what I want is to see, can go close, 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 and this time we have more detail than we had last time. So this actually, the amount of detail we see here is pretty enough for me, for the terrain I'm looking for. I'm not looking to have very high detail terrain anyway. And of course, you know, this is the spaceship, and you are falling toward the surface, and you can see here, whoa, what happened? The camera reversed a bit here. So you can see we have hills, we have, yeah, so we have to add the variation there. Oh, what happened? I think the collision, oh no, actually, no, the collision is fine. So what I want to do now is, as you can see here, it's very regular because it's defined just by noise. So the big question is how we can layer noises so we can have hill valleys and more organic detail that resembles an actual terrain instead of just like now it looks more like an asteroid than actually looks like an actual planet surface. So yeah, so level detail works really nice. I need to work around with the detail and start to experimenting and see how to make it work and see more realistic there. But already it's pretty good. Now I may have actually, how large is the radius for this one? The radius, if I go to the low terrain. Now we change here the bounding boxes with 2000, 2000, 2000, which is fine. I was thinking actually doing that. I'm not sure about what this one is, X, Y, and Z, what that means. So you have width, height, and depth. So the big question is, because right now, let me remove the view. Right now the sphere doesn't really, I mean, I can actually make it consume more of the, how much is the radius? The radius is 600, so I want to increase the radius to 2000 actually. Let's regenerate it. So now it should be outside the radius, so I have to, because I see, yeah, let's see how big it can be until it goes outside the radius. So this is 1200. No, wait, what? Okay, let's say 900. Okay, 900, 1000. That's actually very interesting because in 1000, I think, yeah, because, because if it's the width is 2000, then the radius will be 1000 because of the width is, you know, double the radius. So we need to double, that. We need to double these dimensions here. So we have to go for, I think 96 to 496. Because I would like the radius to the planet to be 2 kilometers. I'm not going, wait, what? 496, why it's 4608? 496. So as we can see here, I don't think I don't understand. Maybe, yeah, I have to regenerate it. So you have to regenerate it. No, why is it not in the center? Why is not in the center? I don't understand this XY here. What is this? So, okay, let's take a look and make that 0. Oh, okay. So maybe minus 2048. Okay. I don't understand how this works exactly. 2048 and minus 2048. Okay, so now it's in the center. And now I can actually go here and also fix the radius, which I wanted to be 2000. If I regenerate this, now we have a 2-kilometer planet. Okay, let's take a look how that works in real. So of course it's a lot closer, right? It's a lot bigger now. Now that means we're gonna have a lot more detail when I go to the surface. So we can see here the surface has a lot more detail. But yeah, so far I don't really see any big problem. Still, the detail seems pretty similar. But yeah, the surface will be a lot more organic. Right now it has a lot of detail that it needs to be because it's a very rough terrain. Okay, so let's play around. So this is actually the size I'm going for. So this is basically a sphere 2 kilometers in radius, which is going to be the planet. The planets will not be real-life planets because the problem is that, you know, a planet like Earth has 6,000 kilometers radius, but that means that you get to play around with massive numbers, and because of floating point errors you can easily get, you know, because floating points, you know, they are not precise. The larger the numbers, the more the error you get. So it's you have problems like, I think, snapping and, you know, jittering and all this kind of stuff you have to worry about when you're trying to make out to actually emulate and simulate an actual solar system. So it's a lot easier to go for something a lot smaller. So if it's a planet, only 2,000 radius, 2 kilometers radius, that means you are 3,000 times smaller planet. So you get a much smaller planet in essence. That also affects the distance to the sun. So the distance to the sun is 150,000, and I think goes down to, how much is it if we divide? Is it 500,000 or if it's? I think it's 500,000. No, I think it's less. It's 10,000. I think it's 50,000. Wait. So we have 150 million. 150 million, 1, 2, 3, 1, 2, 3, divided by 3,000, which is because we get much smaller scale. Yeah, we have, no, actually not even 500, it's 50,000. It's 50,000 kilometers, which makes the solar system a lot smaller, right? Also makes it more easier to simulate. So yeah, this is the planet right now. This is the planet right now with the detail, and it's only 2 kilometers in radius, which make it also a lot easier for the player to explore the planet, because there are going to be, of course, a lot of planets that you want to explore. So okay, so let's play around and see how we can take this and make it more realistic for a planet. Okay, so here is the graph. This is the graph that does all the kind of job. So right now I multiply by 10. This is basically gives me the ability. Actually, let me decrease that back to 1. So this is basically amplifies the noise, give it larger values, which means we get a lot more. Okay, let me fix here the camera. We get a lot more variation on the height. Otherwise, if it's 1, I think now the details will be a lot smaller. Yeah, so as you can see here, the details disappear because we go back to 1, and we see that we now get a surface that's more marble-like. But actually, this is a realistic surface for a plane or for you know, a valley where you're not going to be getting hills as much, so you're going to get more or less a flat surface, which is exactly what we achieve here. So if you have something that allows us to filter noise, in some areas to have flatter surface and other areas to have hills, so we can get from his to back to something like this. So I want to go somewhere between those two different things, right? Yeah. So I want to go back between those two different things. Ollie boy. Oh, hello. Welcome to the stream. How are you doing, man? So the big question is, how are we going to do that? We can do that by using some kind of filtering process. So how am I going to be doing this? Right. So this sphere here is the actual sphere. Good mate, just going to sit and do some development. Whoa, what is that? Co-development with you. I haven't touched a Godot in a month. Wow, you're like me. I haven't touched a Godot in a month as well. In several months, actually. Yeah, any help is greatly appreciated. So we're gonna be doing basically here geometry nodes like we do in Blender, but we are gonna be doing it using the Godot voxel tools and see what happened, how I did that. And see, I probably clicked outside, yes, right. How am I gonna do this? So, okay, let's take a look at what kind of nodes we have. For some reason, the nodes are spawning always outside the window. So you have to take the word for it, because I cannot display you the nodes right now. For some reason, it displays them outside the Godot window. Maybe it's a bug with Godot, but I don't want to rebuild Godot right now, because if I rebuild Godot tonight, it's going to be a lot of problems. I probably I will try to rebuild Godot this Friday, or this weekend actually, when I'm not going to be streaming, because I don't want to waste my time dealing with build bugs and all this kind of stuff. Okay, so we have a constant, we have input x, y, and z, which is basically what we have here. This is basically x, y, z for every voxel. And we use this one to generate a Sdf mesh, Sdf sphere mesh. Then we have output, of course. We can ask Sdf, which the output is here. The output Sdf, of course. And then what we have weight. Output weight, I don't know what that is. Type and single texture. So we can also output it into a texture, which is nice. Output type, I don't know what weight and type really, however, is. So what we care about is the math. So math, we have add, subtract, multiply, divide, sine, floor, ABS, square, fractal, wrap, min, max, distance 2D, distance 3D. Now distance function is very important because sine's distance fields, of course, measure distance. Normalize, expression, I don't know what expression, I hope that expression is basically, yeah, you can put probably here 5 plus 3, and it will output 8 basically. So you can put basically some kind of math here and use that. So let's delete that, and then we have expression, power, integer. Whoa, let me do that again. We have a power in, well, come on, power, power. So I can see the menu is actually outside the window, so I cannot really take it inside the window for you guys to see it, unfortunately. So we have a power of integer and simple power. I assume this power is floats. Then we have compared, statify. Statify is important if you want to do things like look like that's gonna look more like Minecraft. Clamp, again the same thing. You can clamp values, clamp C. I don't know what clamp C means here. Mix. I don't know. Mix. That can be also useful. Remap. I don't know what that is exactly. Smooth step is basically a way to smooth out. This is actually used when you join two different Sdfs. You can use smooth step to make a smooth transition between these two. So it's basically like a boolean with a wrap modifier on top of it. So something that allows you to unify two objects, two meshes, but smooth the result, make that a much more organic union, which is very useful. This is something I think that is used most likely in No Man's Sky, because I know that they actually have static meshes. They don't procedural generate the entire mesh. They have a static mesh for the creatures, but the way that they melt those parts together and they join the part together because usually a creature can be made out of several parts. They use something that allows them to smooth out the textures and smooth out also the mesh itself, so you don't really see any seams and any sharp areas where the joints are. So smooth step is useful for that. Curve, I assume here it's like in Blender that you can use a Bezier curve to allow you. Let's take a look at this. So it doesn't seem to have anything. It has a next value here. Okay, here we have a curve. Okay, so you have a curve, and we can define a curve. Okay. So basically, this one probably is used as a way to influence the surface, so that can be useful as well. What else we have? Convert and select. I assume this is selecting between two values. Let's take a look at this. Select A, B, and T. And how it makes the selection? It doesn't say. Yeah, I have to take a look at the documentation for that. Okay, so let's take a look. Generate. So generate has... I'm really annoyed that I cannot actually open the menu so you guys can... Okay, you can guys see it now, I think. So generate has noise 2D, noise 3D. So noise, here's the fast noise 3D we are using. We can use also an image. That also can be useful if you want to do something more static, but of course we want to do something procedural here. So I'd rather use some kind of fast noise. It's called fast noise because you use the fast noise library, which is written in C. And it's, as the name says, it's actually pretty fast because it means to target performance. So we have fast noise gradient. I don't know what that is exactly. Fast noise gradient is here. We can create a new fast noise gradient, and if I open that, okay, it is a gradient, right? So how you define those values? X, Y, Z. No, that's the sample points. So how you define the color, the fractal, octaves, blah blah, which is the typical noise here. Advanced rotation type. What is the rotation type? Improve X, Y plane. No idea what it is. So value, open simplex. I think this is the same with this fast noise. Open simple. This one has more value actually. So it has a period and warp noise, where this one has. It is different. It has an amplitude and a seed, and a period. Okay. Fractal type, octave, lacunarity. Lacunarity. So to explain how noises really work, noises work on an idea of octave. So basically, what that means is that you have something that adds detail, general detail. Then you have something that adds more specific detail. So basically, it's like a bit like a level of detail. But the difference with the noise is that you don't go. It doesn't depend on how far the camera releases. It's a standard detail that goes smaller and smaller for each octave. So each octave, the more octaves you have, you add more and smaller detail. And lacunarity controls the chaos of the noise. So how random the noise really is. So if you go to 1, I think it becomes much more regular, or is it the opposite? I think as you go to 1, it's more regular, and the more you increase the values, it becomes more and more random. And this is the gain, which basically means because noise is basically hills and valleys, it means how large the hills and how intense the detail will be, how high the value is going to go and how low in essence. Which is important when you have to do like high hills and high mountains and deep valleys, etc. So I don't understand how it works here in terms of gradient. But maybe it means because there is also gradient in mathematics that you can use sometimes to calculate the normals in an Sdf. So maybe he means that. So maybe this one is used more as a normal map. As we can see also from the coloration here, it looks a bit similar to a normal map. But we're gonna keep it around, just in case. So that's the nice about the Sdfs is that not only you can generate geometry with them, you can even generate texture maps, you can generate details, you can generate lighting, you can generate fog, particle effects. The Sdfs have a very large area of application. You can use them. As a matter of fact, Godot uses Sdfs for global illumination. And I know that Unreal and Unity uses Sdfs for ambient occlusion, which is both of them has to do with lighting. Because Sdfs do tell you also the lighting information, which is what we can do with gradients in terms of normals, which it's more related to lighting than actual geometry. So, how are we going to do this? So, how you filter one noise from another? Actually, what we can do, what if can I do it through multiply? So basically what I need to do here is has one fast noise. With the fast noise here has an amplitude of, what is the amplitude? Gain of 0.5. So that what gives us very small amount of detail, which is already does here. Actually gives us a lot of detail. Wait. What I'm missing? Oh, no. It's not the... Yeah, I multiplied it through the gain here through this multiplication. So I want to use a noise as a mask to filter some details. So, okay, so before proceeding, let's go with... let's open documentation of voxel tools first of all. So Godot voxel tools. It's here. What was the last time he actually committed? 13 hours ago. So Zealand made a commit 13 hours ago. He still has problems with the build there. Let's see what the problem is. Now I want to take a look at the problem. Okay, let's open that. So it says here it fails. Fix for what? Some checks. Push in, okay. Okay, so there are some fails here. Right, okay, let's go to the documentation. Documentation. So this is basically what you can do with this tool. This is the kind of terrain I'm aiming for. Actually, this is the kind of terrain I'm aiming for. So something between those two. Okay, let's go to the main documentation. I wanted to take a look at the documentation when it comes to terrain types, to the voxel low terrain, because this is what we're using. Actually, no, I'll go to the smooth terrain. Okay. how the stream is for you guys. Let's take a look at the stream. Oh, it's okay. It's okay. I think it's great. Okay. No issues here, but it's in the background for me. What do you mean it's in the background for you? Ah, you mean you don't see it full screen? Yeah, that's fine. So what I'm doing here is I'm reading the documentation to make sure that I have a good understanding how the voxel tools works. As I said, it uses something called Sdfs, science distance fields. Science distance fields are a way to describe geometry mathematically by measuring distances from a point, a random point you may take as a sample point, to the surface. The distance from the surface is also going to be 0 if you are on the surface, positive if you are outside the surface, and negative if you are inside the object, underneath the surface in essence. So that's what Sdfs are working on. So you can use a very simple equation to measure the distance to the surface of a sphere using x squared plus y squared plus z squared plus, actually no, I think it's a minus the radius of the sphere. Because of course, the larger the sphere, the closer you are to the radius. So basically x, y, and z is the position of the sphere the position of the sphere in the world coordinates, and radius, of course, is the radius of the sphere. So you can find every single time, taking a random sample point on the screen, you can find how far it is from the actual surface of the sphere. Of course, if you have more complex shapes, like not a sphere but something that's different, you're going to use more complex mathematical equations to emulate those surfaces. And the nice thing about Sdfs is that they're very easy to calculate. It's just addition, power, division, multiplication. You don't have to do anything specially mathematically complex to calculate those. And they also give you infinite detail, because it doesn't matter how much resolution you have in the screen. It doesn't really matter how many details you want to have. The math always will actually produce the details you want, and everything is generative in essence. So you can use things like noise, etc., to generate all sorts of random detail, which is why Sdfs are heavily used in everything we do. An example of how you can use Sdfs and a technique called ray matching, which is an efficient way and a very simple way to render them. You can go in websites like Shader, and there you're going to find countless examples of Sdfs. Everything here, from simple shapes to realistic terrain. You go here and you go to by popularity. Where is the popular? You have things like water. You can do water. You can make complex terrain, which is what I'm trying to do here, which is this one, which has also vegetation on top of it. Even the vegetation here is procedural generated using Sdfs. The clouds are created through Sdfs. The light is created through Sdf. The fog is created through Sdf. So you can do pretty much a huge amount of things using Sdfs, because you can use them to emulate pretty much anything. As in, I'm just not fully paying attention. Oh, that's fine. Okay, so that's how this works. So scaling and clumping what allows us basically to have things that are more blocky. So Transvoxel is a technique that is used for having voxels. And by the way, when we say here voxels, we don't really mean just Minecraft voxels. You can use voxels for emulating any kind of surface. And this Transvoxel algorithm allows you to have, because one of the biggest problems for using voxels is that you can have seams and you have gaps in the geometry. It's a pain in the ass. So Transvoxel basically allows you to avoid that. It's a much more efficient algorithm. Marching cubes is the one voxelization technique that is heavily used. So let's say you have an Sdf, right? So the big question is, when you have an Sdf, when you can't define a procedural geometry using mathematics, that's all fine and good, but you have to render this. And GPUs prefer if you render things in triangles. So how you take something that's purely mathematical, that has infinite amount of detail, because you can use math to calculate. It's like a fractal, basically. You can zoom in infinitely, and it's going to have infinite amount of detail. How you can take that and make it to something more static, which basically is going to be a mesh. It's going to be made out of triangles. And you can use something called a mesher. And a mesher basically takes something that's mathematical and turns into actually a finite thing, which is a mesh made out of triangles, vertices, edges, faces, like we are used to do if you do conventional like gaming or if you do blotter modeling. That's how you deal with it. One of the most popular algorithms for doing that is called marching cubes, and it basically divides your geometry, your mathematical geometry, into cubes that of course calls voxels, and it calls them basically cubes in essence, and it goes from one cube to another. So it takes every single cube, one after the other, and marches through those cubes, which is why it's called marching cubes. And every cube, depending on where it intersects, because it has to intersect with a cube, because if the geometry doesn't intersect with the cube, it means that the cube is either completely inside this 3D geometry, which is of course an Sdf, or completely outside. If it's completely inside or outside, there is no geometry there to generate. It's just empty space. So it has to intersect. And depending on how it intersects, the matching cubes has a table of possible scenarios. It picks one of those options, depending on where it intersects, the surface where it exists, and generates faces for you, and then it assembles all those faces one after the other until you have an actual mesh and a full geometry of the 3D geometry. The thing with the merging cubes is that you don't get as much precision, because those scenarios are not meant to accommodate for every possible geometry you're going to have. Usually merging cubes produce a bit of more blobby surfaces, which is why if you take a look at No Man's Sky, you may see that everything becomes a bit blobby, or if you play Spore, you may ask yourself why everything has to be blobby. And the answer to that is because most of the time they use marching cubes or some kind of algorithm similar to that, and the algorithm is just not that precise, because if it becomes very precise, it becomes more expensive. So you can have algorithms that are more expensive. Now, the disadvantage of doing things in geometry like this is that it creates a lot of messy, very clumsy topology. So this is not really a replacement for making and modeling your objects manually like you do in Blender, but it's a great way to generate, thousands and thousands of models using simple algorithms. So Transvoxel basically is an extension of matching cubes that can be used to create smooth meshes from voxel data. The advantage of this algorithm is to integrate stitching on different levels of detail without causing cracks. So basically stitching here is that because essentially you have two big problems. The first one is the matching cubes assembles meshes together. So those meshes in those different face data is disconnected from one another. It's not an entire mesh, it's constructed in real time in essence. And sometimes if you have a level of detail, that means that you have meshes in different resolutions that have to be stitched together. They have to be connected into one single mesh. Otherwise, if they're not, you're going to have seams, and the player will start seeing seams in the geometry, like in terrain, for example, and that is going to be very destructive. So even in worst case scenario, you can even have gaps. So that's exactly what Transvoxel is doing. It allows you to stick things together, fill up the gaps, and make sure that everything becomes one seamless geometry. So it can be used to render very large landscapes. Transvoxel uses special meshes to stitch blocks of different level of detail. Exactly what I was saying. However, the seams may still be visible as occasional sharp little steps. We see here that is not perfect. So I complete and then continues to smooth them out. So to eliminate any. So it's not. It doesn't really have gaps, but it has edges, basically sharp edges in some areas that the stitching happened because there can be a sudden drop of, for example, on the height of the surface or some bump, some kind of sudden bump in that area. So it creates kind of a smoothing effect that allows you to smooth those areas and get a much more organic result. So this is one of the things I don't really understand. I think this one is a vertex shader. So basically the engine, the voxel tool engine allows you to create also your own shaders for defining the geometry. Yeah, this is it's a vertex shader. Here's the vertex function. So wait a second, what exactly has... so we have an int here, a border mask, this is an int. No, I think this is a simple vertex shader. It doesn't seem to use anything from the Godot, from the voxel API. I don't see any kind of... This vertex color, I think it's a standard vertex color. Value, I don't see anything different. So use the custom 0 information to smooth out the vertices. I don't have to. Well, we're gonna use this shader if the need arises. Right. So texture in procedural generated, because all those things here, even though they look, these cubes may look that they are just simple cubes, meshes, but in reality they are Sdfs. They are mathematically created, and you can see here that it's not as sharp. You can even smooth out even further using the smooth step. But the big question is how you texture map a completely procedural geometry. And the most popular way of doing that is called something called triplanar mapping, which basically takes the x and y and z coordinates of the actual surface and maps the texture on that. Of course, that's not the ideal way of doing it, because we can see here that, you know, you have a mixing of different direction of the texture. So you have here the texture coming from this way and mixes with the texture going from this way, because this one is probably the y-axis, where this one is the x-axis, and this is, you know, probably the z-axis that comes forward. So you have this kind of mixing of textures together, which in that case scenario, in this case scenario, it doesn't really matter, because you can see here you have an up and down left there because it's a cube, basically. It doesn't matter. But when you have a sphere, it does matter, because, you know, it doesn't really mix them well together. Omoni says, or maybe just avoid textures and do basic colors. There are ways to do this. If I give you an example, for example, I go here and let me find you one example of texturing that works very well. This also uses all those things. Here's an example of triplanar mapping. This uses Sdfs. So this is distance fields. It doesn't use a voxelized algorithm because it doesn't generate a mesh in this case. This is only mathematical, which is why it has so much detail. You're not going to see any edges here or any triangles. And this is textures. You can see that even though it uses triplanar mapping, you can still have beautiful smooth transition depending how you generate the texture. So if the texture is completely procedural generated, triplanar mapping is not going to be a big problem. It's going to be a problem if you want to map an existing texture, you have an image on top of triplanar mapping. You have to do some kind of smoothing together and blending them two textures together in a way that the user cannot really see the transitions between the different axes. But when you do the texture completely procedurally, like in this case here, I can actually zoom this out so you can guys maybe see the details here. It's actually a lot smoother, and you can have a lot of nice variation. So yeah, it's this possible if the texture is completely procedural. Or you can mix also static textures like images and procedural textures. So you can do a lot of things. You can play around with a lot of the different ideas. In my case, I'll go for low poly, so I don't know if I will be using textures and how I'm gonna be using, so I haven't decided. I decided to go with something as simple as possible because this is my first game and I want to make things very complicated. So I'll probably go for low poly and probably I will not be using textures at all. I was thinking a look a bit like, let me, low poly, sci-fi, something similar to this. So something similar to that. It does have a bit of a textures here, but they are only barely noticeable. The mass majority of them is just regular, I think, probably simple materials on top of surfaces. So you can see here, yeah, it's basically a kind of look I really like. I was thinking of going a bit more detail though. Yep, that's the asset that I'm using in Unity in my prototype. Yeah, this is actually a very popular asset pack. I'm thinking of going a bit more detail though, not really that low detail. But yeah, I do like it because you can see here, even though they don't use any textures. I mean, the textures are here, a bit of texture here. But if you take a look at most of the models, don't really use any textures whatsoever. Apart, of course, yeah, the images here and all this kind of stuff. For example, here you can see there's a bit of texture here, but only barely. And you still can, for example, this one I don't think have any texture. This thing here. And you can see how beautiful detail it has nonetheless, right? Still, even with very basic textures, you can go a long way in making something really visually interesting. So this is a very good, asset pack. Obviously, the people behind making this are experts in low poly, which I'm not. But you use something as inspiration, and you don't have to end up with something the same quality. Just something. Look at these vehicles, for example. I really love it. The designs are very, very nice. So yeah. So probably I will go for something like that, a bit low poly. We'll see. We'll see. Okay, so where I was here. Triplanar mapping in Godot. Is there also an article for triplanar mapping? There's. Okay, so Godot has triplanar mapping. I didn't know that. Oh. So this is actually a Godot feature. Okay. Okay. Great. So you can auto texture basically. I think Blender also has triplanar mapping, if I'm not mistaken. He calls it world coordinates texturing, I think, texture UVs. So you can actually have a choice to use triplanar mapping also on Blender if you want to. Okay, so there's an FPS demo. What is that? Voxel game. So maybe we have to download all those demos and see if we can make them work for ourselves. I wonder. Maybe download all of those demos and see how they work. It would be a good idea. Is it a bit project? Oh, it is. It is. Okay. So how I'm gonna run those? I can actually go and put them... Okay, so let's do that. Where's my command line? Here it is. Let me open a new tab. And let's clone this using Sdfs. And let's go inside coding. and git clone this example, voxel game. So let's take a look at this and reverse engineer it and see and play around with it. Actually, this is what I'm gonna do. I'm gonna play around with these examples. And I know there are other examples as well. There are some demo scenes here as well from Zealand, which I may have to clone as well. I'm gonna clone those as well. Yeah. So how are we doing? 82%, nice. So yeah, we're gonna be taking a look at those and make sure that we understand exactly how they work. Let me continue with the documentation for now. ABX, ABMX1, MX2. So here we see a transition of texture depending on the, I think it's on the angle of the terrain. So depending on the angle of the terrain, so we can see here the angle is sharper going downwards. You have this texture, but anything that's flatter has a smaller angle. It's, of course, it's grass. This is very useful if you want to make, you know, grass that's only on flat surfaces, basically. Which is really a great idea. And you can do the same thing for snow. You can do the same thing for wet surfaces. You can do the same thing with lava, so this could as well be lava. Or water, some cases. It's actually pretty useful. Yes, no, here. Procedural texturing is what I was talking about earlier. Okay, so this one is ready. Let's also take the Zealand as well, code as well. So here it has to have, let's see, ls. No, that's Multicubes. What was that? Voxel game. So it was the, oh no. Oh wait. It's a fork. Okay, so I'm not gonna play with it. I'm not gonna get Zealand as well then. Okay, if it's a fork, I'm not gonna touch it. Okay, so the big question is how am I gonna make this now? Actually, no, I can go inside the executable and open it from an executable. Yeah, let's do that. Let's open a separate instance for that. Okay, so I'm gonna use the browser here. And I'm gonna open it. I'm gonna open the example separately. Coding. Oh no, actually no, sorry. I'm not gonna go through that. I'm gonna go through Keyclops, coding Keyclops, bin, Keyclops. So this one is gonna open the manager for me, and I'm gonna import from coding voxel game. I'm gonna import this one. Project Godot. Open that. Import and edit, yeah. By older version and needs to be converted to the new version. Okay, so I don't know if this is gonna work because I don't know if they actually made for Godot 4. So there may be problems there. But nonetheless, yeah, we already have problems with the errors. Has broken dependencies. You cannot find some dependency, the shader. Okay. Let me resize that. Yeah, probably this is gonna need Godot 3 to in order to work. You're probably gonna need Godot 3. don't know if I can open with all three. Ah, here's the terrain. Ah, okay, here there is a terrain. Okay, wait. Let's run it, see if we can run anything. Nope. Oh, it loads still. Wait. Ah, there's an error. Yeah, it's not gonna work. It's not gonna, it's for Godot 3. Unfortunately. Maybe... Okay, let's stop that. So maybe if I can find Godot... Where's the don't I have Godot? I have Godot here. In Steam. Okay, let's see if I can open it with Godot here. So import... Let's go coding. Let's go voxel game, project. Project Godot, just open that. Import and edit. Let's see if that's gonna... Nope, that's not gonna work. Yeah, because unfortunately I will have to re-download it, that's fine. So rf voxel game, so let's delete that and let's clone it again. And I will use Godot 3 to actually take a look at this. Yeah. Okay, so I'm gonna launch Godot 3 again, and I'm gonna go with import again. This one should work. The reason why I didn't open last time because I opened it with Godot 4, and every time you close a project in Godot editor, it saves the project. So basically, it saved it as a Godot 4 project, even though it was a Godot 3 project. And of course, when I went back to go open it with Godot 3, it wasn't working. Now it should work, if I'm not mistaken. Yeah, it works without any issues. Okay, we have to wait a bit to import the JPEGs. And whoa, what is that? Unexpected end of file height map. Smooth load TSN. Why there's errors? Why the hell there are errors? That's not good. Okay, let's try once more. That's not good. Import again. Gross, coding, voxel game, project code, open, import and edit. Unexpected end of file head map smooth load TSN, which means what? Okay, let's size that so you guys can see it. Let's go with DMC terrain. What is we have here? Main TSN. Unexpected end of file main TSN. Oh, it doesn't really work. There's something with the files. Yeah. It doesn't like the files. Weird. Maybe it's for the older version of Godot. Maybe they are made with an older version of Godot. What was the last time this one was updated? This one was updated last time in March 2020. Yeah, it's very old. What about Zealand's voxel game? 5 months ago. Okay, so I'm gonna go with the Zealand's then. Let me copy that. Copy. Let's go back to the terminal. Let's delete again the voxel game. Is it deleted? Yeah, so let's now do git clone and this time put the Zealand repository, which is most recent. And let's see if that actually help us make it work. So I don't think... So it has been updated. The last time it has updated what? It has a script there. Okay, let's take a look at the project folder. The project has been updated, yeah, almost a year ago. Okay, let's hope that this one maybe helps. Okay, so let's open Godot again, Godot 3, and let's import the project again. Okay, it works. They don't see any errors. Okay, let's go with smooth terrain, and let's go with main TSN. Nope, an expected end of file main TSN. I don't know what the problem is. Doesn't seem to open the files. I cannot make open the files. There's some kind of error that doesn't like. Wait, what about Godot? This one Godot 3, right? Yeah, this is Godot 3.44. Wait, is this the latest version of 3.44? I think. Is it 3.5? It's updated in Steam, so I don't think it's the wrong version. Yeah, it doesn't seem to open the files. There's a problem with the files. Let's see, blocky game TSN. Nope, the same problem. Blocky game TSN, unexpected end of file, blocky game TSN. Okay, let's report that. First of all, let's take a look at the project itself. Runnable scenes. So it has a smooth terrain main TSN. So that's correct. Why the hell doesn't open? Coding, voxel game, project. Oh, wait. No, I think it's correct. Okay. So let me go back. 3.44 is the latest table. So the latest table 3.4 and I have 3.44. Okay. So it's not my problem in my end. Terrain curve. Yeah, there was the only. Wait. Let's open it. TRS. Main TSN. Unexpected end of file main TSN. Yeah, maybe I'll have to report this. Make an issue. Okay, let's take a look. If there's any issues here. Keep getting an error. No, that's different. I don't see anything. I have a similar problem. Wait. I have to log in. Smooth terrain, right? Yeah, smooth terrain. .44 stable efficient. 4 stable efficient. Let's leave that as well. Into Discord. And let's ping Stilan. And that's it. Okay. Let's see what we will see. So that's another problem we found. And okay, let's take a look at the project regardless. I cannot open the TSN file, but I'm able to main TSN. Let's take a look at the code here. I see also an error here. Voxel server. Wait, this is new game project. Why it says here new game project instead of the project itself, which is voxel game. New game project. I don't know. This is a shader as well. Yeah, let's take a look at the shader. What shader is this? This is a vertex shader. This is a vertex shader. Ah, it's also a fragment shader as well. Oh yeah. Oh yeah. Oh shit. Ah yeah, of course it's not gonna work. it includes the Fox tools. Yeah, so I don't think you have to build Godot 3 in order for it to work. Now, okay, it's not gonna work now. I'm not gonna go down building Godot 3 with this. I have to fetch a binary for that. I don't know if it's. I don't know if we have binaries right now. So okay, let's delete this issue. Can I close it? Can I delete it? I cannot remove it. Yeah, that was a bad idea. So I have to find some kind of binary. So you don't have to recompile to import the C++ module? Yeah, I have to recompile to import the C++ module. You have to build the engine with the module, to be precise. Because the module becomes part of the code of the engine. So I completely forgot about that. No idea how I forgot that, because I already built it. I already built the voxel tool with my version of Godot 4. So what I'm using here is my own version of Godot 4 built with a module of voxel tools, which is why it works. And completely forgot that I need to do the same with Godot 3. But yeah, if I can find a binary quickly, I may be able to access the project. I mean, I could build Godot 3 with a module, but I don't know if it's gonna work with the module right to the box. Yeah, I don't want to mess with building right now, because I may have wasted too much time for no reason. I'm gonna do it maybe later. And I don't care about Godot 3 anyway, I want to focus on Godot 4. Let's see if we can find Godot voxel tools binaries. Blah blah blah. I think there were some binaries, but I may. First of all, I need binaries for Linux. I don't think we're gonna find binaries. Yeah, probably we'll have to build it. Okay. It is what it is. Okay, so. Okay, let's take a look at the repository then. Where's the repository? Cannot open blah blah blah. Let's take a look at the code. Project, smooth terrain. So this is our PNG files. Yeah, this is our PNG files. I may try to convert it to Godot 4 if I wanted. I don't know how much conversion I need to do though. So open it with Godot 4 may not be a bad idea, and then go and fix all the errors in there and make a pull request for Godot 4. I can do that as well, if it's not too much of a trouble. But I don't know how the shader language has changed. I think the shader language is different for Godot 4. And I will have to change also the scripts here. So the onReady doesn't exist anymore. I think it's a decorator now. And God knows what else is different. So okay, I'll give it a try to port it in Godot 4. Okay, let's give it a try to port it in Godot 4 then. Okay, so the way I'm gonna do this is go to the folder, open it, and do the same thing I did earlier by importing it, coding, voxel game, project Godot, import and edit. Yes, it's gonna complain that it's with the earlier version of Godot, which is fine, and they're gonna convert it to Godot 4, which is fine. Okay, and it's gonna have problems. Actually, I'm surprised it doesn't have any problems. Okay, so if I go to smooth terrain and trying to open the main TSN, it says that due to missing dependencies, there's one that's called Transvoxel Terrain Material TRS. Well, that's weird because fix dependencies. Wait. It says that smooth terrain, transvoxel terrain. Okay, let's take a look at it. There's a transvoxel terrain material here. Fix dependencies. Transvoxel material here. Okay. Terrain material. Open. Okay. Why it says that dependencies are missing? Since smooth transvoxel material TRS has broken dependencies. Terrain shader. Terrain shader. What is that? Okay, this is the terrain, but it's... Okay, so let's go to the dependency that's broken. Okay, so what is broken exactly? So terrain, material. So okay, so let's take a look at the terrain. Where's the terrain? The terrain is here. Where's the material? The material is here. So the material is empty. Okay, so load the smooth terrain material. Open. Nope. Nothing happens. Why? Why it doesn't work? Why it doesn't work? That's a good question. No, it doesn't like that. Okay, so let's open that. Nope. Okay. Okay, let's open the TSN then. The TSN is this one, okay. What is that? There's a noise. What is that? Noise. Voxel generator noise tier. What is that? Voxel generator noise to de-smooth. I don't think this terrain is what it's intended to be. Okay, let's say preview the terrain. Select here as the main scene. Nope, we get errors. Okay, so what is the errors? So let's see how many errors we have first of all. We have a lot of errors. So we have, first of all, I think those. There's no on already here. var. So it says here, mesh instance was not found in the gyroscope. Okay, let's take a look at the output. Let's debug here. Let's go with errors. Why there's no errors here? Okay. See, sometimes I cannot understand how the hell is going on. Okay, so 101. So here we have a first error, which basically says there is no such thing as mesh instance. Okay. There's no mesh instance. Okay, let's find mesh instance in documentation of Godot. Mesh instance. So this is in Godot 3. Okay, so in latest, what is it? So latest basically is the Godot 4 documentation. There is no mesh instance anymore. Okay, so this one was in classes mesh instance. So there's no such thing as mesh instance. Okay, so what exists? So if I go to API, there's nothing called mesh instance. Mesh texture. There's a mesh library. Mesh instance. It's called mesh instance 3D. Okay, so let's change that to mesh instance 3D. What the hell? What is it doing? So we have to change that to what? Wait, what error? Why did it? What? What happened? What is that? Seriously? Where's the error? There's no mesh instance anymore. How that happened? Where am I? Okay. So it was. No, that's the only. What happened? Where's the error? Why it sends the error? Mesh voxel server. Now it talks about a voxel server. What the hell's going on? So voxel server is part of the module, I think. So why I cannot find that? Wait. Maybe I'm in a different project? Wait. Let's quit that. Let's close that. Yeah, here it is. Okay. Let's close that. So it was another project I have open. Okay, mesh instance 3D. So that should change to actually fix that error. Is it with capital? Yeah, it's capital D. Okay, so this is so mesh instance 3D as well. Okay, another problem I have is spatial material doesn't exist anymore. Okay, let's see how it's renamed. Spatial material has been renamed to spatial, whatever it's called. Is it completely removed? Spatial material. Yeah, it's completely removed. How it's called right now? Spatial material doesn't exist anymore. Maybe it's called just material? Yeah, it's not here anymore. So let's go with material then. Material, here it is. So inherited by base material 3D. I think it's called base material 3D. Canvas item material, fog material, shader material maybe? That's I don't want to know which one is it gonna be. Standard material 3D. Maybe it's called standard material 3D. Maybe it's called standard material 3D? Let's go with standard material 3D. 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 Do we have any errors? Okay, so what's the problem here? Connect on canvas item draw. Okay, what's the problem? Immediate geometry. What is immediate geometry? Here it is. Immediate geometry. Okay, let's save that. Immediate geometry. I don't think there's an immediate geometry anymore. I think this one's removed completely from Godot 4. if I'm not mistaken. Let's see. Immediate geometry. Yeah, converting things. This is why I don't work with Godot 3. Because converting things from Godot 3 to Godot 4 is such a pain. Okay, there is still a geometry 3. So, why? Extend immediate geometry. Wait. What is that? That was immediate geometry. So why I cannot find that? Immediate geometry. Why I cannot find that? That's correct. Immediate geometry new begins at color vertex. So how it works exactly? Okay. Let's take a look at it again. Begin. There's a begin. So what is that? Is it global function? That must be local function. Okay, I'm not gonna waste my time anymore with this. It's gonna require a lot of magic to make this work. I'm not gonna bother with that. Yeah, close that. I have no idea. They're gonna be like a gazillion of errors. Okay. I'm gonna take a small break just to rest my legs a bit, and I'm going back, guys. Okay, so let me start playing around with these things here. That's a preview of the Vivo. What happens if I put another fast noise here? Can I replicate this? How do I replicate this? Can I? No. Can I? No. Can I? No. Okay, so I'm gonna put another fast noise there. It's gonna be fast noise 3D. Fast noise 2 3D. Let's go with just fast noise 3D. And what I'm gonna do is gonna go and find 64. Okay, so what I'm gonna do with this, I'm using one to multiply the other. So let's make a multiplication as well here. And instead of doing the other, I'm gonna do this. And this, and then do the multiply there. Wide complaints. I need the x and y. Okay, so I'm gonna use the same x and y here. So whoa. Y there. So why it's red? Why you are red? Why the hell you are red? Maybe because you don't have a noise. Yeah, that's why. Okay, so this one had 64, 62, 0.5 and 2. 62, 0.5 and 2. This one is gonna be... Let's make this 3, 2, 0.5 and 2. Yeah, and let's see what happens in that case. And basically, I'm using one to multiply the other, which means that it should add multiple details. Okay, let's take a look at how it looks in real practice. Okay, so we see a different result here, but not the result I wanted. So it still is pretty smooth, but it has areas that becomes... Yeah, this is maybe some kind of thing I want to do. Okay. Actually, let me put it outside and use that as the way to see if I am able to see an update real time. So if I go here and say fast noise, open that and increase the octaves to 4, 5 or 6, it doesn't affect that. So this one remains the same. What if I relaunch this? Does it remain the same? Yeah. Weird, why? Why it's the same? Oh, wait. It looks the same. So it looks here like a moon, more like a moon which has craters. Although that doesn't look very much like craters, they're a bit irregular to be craters. But it is... yeah, it does something to... it gets there slowly. Let's take a look at this one. Let's remove the noise again there. And... what if I go the grain and the grain to 10, for example? Okay, actually, yeah, I can preview it from here. I completely forgot that. Let's remove the octaves. Yeah, I want this to be much more general. And this one, let's take a look at this. Doesn't seem to affect anything. 0.5? No. Okay, let's go with 4. Nope. 6? Nope. Okay, reset that. So this is the gain. Okay, let's take a look at 1. Nope. That's weird. Okay. So let's do 10 for this one. What about rigged? Okay, this is nice for if I want to make like actually let's look at this, how it looks with that. I don't see much of a difference. Well, I kind of see a bit of a difference. It does start to look a bit like a terrain, but still I feel there's too much noise that is not the way I want it to be. What about the period? Okay, the period does play a role. Okay, let's take a look at it again. Yeah, I think that is basically the way it defines the ridges there, because there is definitely a ridge like a sharp, like you know, we see here the tail is a bit of sharper. So there's definitely a bit sharpness there. Okay. How about the octaves? So the octaves add a bit of detail there. Okay, let's see what happens if I add a lot of detail. Yeah, you see now more of the actual terrain. Interesting. Okay. So what happens if I go in the first load, the first noise, and decrease the octaves? I make that, let's say, a lot more general. Let's make it, to, yeah, I don't want to be super detailed. Right. Okay, so I want to do the same thing also with the second noise. I want to decrease the detail of that. Although, to be frank about it, yeah, let's make that much more generalistic. Okay, so here we have obviously a nice layer of detail. That actually looks a bit like a dunes, like a desert thing. I suspect that hills there are of the first noise. But still not what I'm looking for. So let's change the noise from ridge to ping pong. Let's see what happens when I have this one, which is very similar, so I don't think I'm gonna have very different results, but let's give it a try. Yeah. That is interesting. That's a really weird terrain. You can really come up with some really weird terrains there. I don't know why it's so jagged though. Yeah. Definitely can create some really weird terrain-like features. Okay, so I'm gonna go back to FBM. And okay, what happens if I do an FBM like that? That's a lot more, but still we get that kind of thing that is happening. Okay, what happens if I don't multiply anything and keep the first detail? So let's say multiply by 1. So this is going to keep the value as it is. And see what happens in that case scenario. Okay, so we see here there's quite a lot of difference in detail. But this one has a much smoother Sdfs. Okay. Yeah, because you multiply by 10 there. Let's multiply by 1. That's a little smoother. Okay, let's say multiply. Let's do something different. Let's say you add. Instead of multiply, let's add. Remove multiply. Instead doing like add. Yeah, this is a more profound effect there. Okay. Oh. See you. Bye-bye, Omoni. See you later, man. Thank you for joining. Zilan, welcome, welcome. Welcome to the stream, man. How you doing? For about 20 minutes. Well, I'm about to end the stream, so welcome and goodbye. Yeah, everything goes well. I don't have any issues right now. I'm just trying to understand how the voxel tools works. I'm reading the documentation and I'm making my first steps into it. So I don't have any questions for you, actually. I tried to play around with your example, but I have to build Godot 3 to use your examples because they're not... I tried to convert them to Godot 4, but it's too much work right now. And yeah, probably we'll have to build Godot 3 with this module to open the examples, so I have a good idea. But overall, I start getting an idea how to do things. They may have a Godot 4 branch for the example. So the example I was looking for was this one, the voxel game. You have a Godot 4. You have a Godot 4. I'm an idiot. Okay. Let's give that a try. So let's go and... Okay, I will actually... Just to be on the safe side, let's reclone this. I didn't realize that there's a Godot 4 branch. Okay, so let's go voxel game. If it doesn't work, I might just update it because I have a working version. Nice. Okay. See the voxel game. Check out Godot 4. Godot 4 branch. Okay, so let's open it. Develops. Import. import bros, coding, voxel game, project, import and edit. Fingers crossed. No problem so far. Smooth terrain. Oh! Ah, it works. Nice. Okay. Let's take a look at this. Wait, what? Wait, what happened? What happened? Ah, okay, here it is. Yeah, so that's a terrain you made here. Ah, you can. Oh, okay. And how you subtract the terrain? Ah, you can go through the terrain. So what is that? Okay. No, it seems to work fine. The collisions. The collision doesn't work, but maybe it's not enabled. Yeah. Actually, the geometry for the spheres are not bad either when you add them. Static memory 140 megabytes. It's not bad. How large is the terrain? Is it infinite? No. No, it's not infinite. But it's pretty large enough. What happened? Why it lost so much detail here? Why when I actually zoom out is must be the distance thing, huh? It clips out. It must be the distance for the load. It doesn't render at all. Yeah. Okay, that's a good example for texturing. That's a nice detail. The terrain is kind of weird though, the way it's shaped. But yeah, it's pretty good. Nice valleys and hills, canyons. I like it. And that's a texture, right? Yeah, it has a texture with some grass in it. It only loads the raid in a large cube around you. Ah, okay. Okay. Oh wait, it's... No, it's not infinite. No, it's not infinite. Ah, it is infinite. Is it infinite? Yeah, it's infinite. It is infinite. Okay. So this example is where it shows how you do the texture there with the transition. Pretty cool. Performance-wise, we get 60 frames per second, which is great. Now, of course, it doesn't have any assets on it. The reason why it says 60 frames per second is because my monitor only can do 60 frames per second. It's not a very fast monitor. Because I bought it just for the colors. It's an IPS monitor, 42 inches. So it doesn't have a very good refresh rate. So it definitely it should be able to do a lot more frames than that. Probably I can go inside the settings and unlock the VSync and do that. Okay, it's perfect. Right. So I'm gonna take a break. I'm very happy that I can take a look at the example. Actually, that's what I'm gonna do. When I come back, I will take a look at the example. I will be back in a couple of hours for another 2-hour stream. But for now, I'm gonna end it because I'm kind of tired. And there's a lot of things to learn. So I have to build the detail in terms of layers here. But I think I will be able to do that. So far, it works well, so I don't have any complaints. Right. And also we get to have the examples working, which is great. So yeah, thanks Zilla for joining us. Thanks everybody for being here. Sorry for being a bit quiet, but I have to get to study and start focus on learning things. So it's gonna be a bit quiet for a few days until I learn how the voxel tools works in detail. There's a lot to learn. There's a lot to play around. Maybe I will do some geometry nodes also tutorials on how to do procedural generation for terrain. I think there are some tutorials on Blender on that. Yeah, and maybe try to port the tutorials to the voxel tools. Or maybe I can use also some shaders in ShaderToy as an example, like this one here, as an example for texturing and procedural generation of meshes. We'll see. There's a lot to learn. The next few weeks will be me studying voxel tools and procedural generation because I want to get the terrain working correctly and properly. We are 4 people here, so we're gonna do a raid. Let's see if there's anyone right now. I don't see anyone. Okay, let's take a look at Twitch. Let's see if anyone is doing Godot right now. We have Dem Spadius as always. I'm gonna give him a round, but let's take a look if there's anyone doing Godot. Godot. Let's see who is doing a Godot apart from me. Oh, I'm the only one doing Godot engine. Okay, so I'm gonna do Dem Spadius as always. He's a great guy. He makes a RimWorld clone, a RimWorld kind of variant, but it's set in space. Thanks people for being with me. I will take a break for a couple of hours and then be back. And then we're gonna continue studying how voxel tools works and trying to figure out how everything's gonna work. So see you guys later. Bye-bye. Bye-bye.